We've been asked for d squared y dx squared, or the second derivative. This is really y double prime. We've been given this equation x, y plus 3 equals negative x. And we want this second derivative at this x and this y. So in order to take the second derivative, we first need the first derivative. So we'll find the derivative with respect to x. Coming from the first term, we have negative 1 equals 0. And now we have the product rule. 1y plus the derivative of y is y prime times x. Now since I want y prime, I'll subtract y from both sides. And we'll have y prime times x equals negative 1 minus y. We'll divide by x and get our first derivative, dy dx, equals negative 1 minus y over x. Well, if we wanted the second derivative, then we would take all of this and find the derivative with respect to x. When we do this left side, of course, that's just our y double prime equals, well, here we have a quotient, a p over a q. So we'll have p prime q minus q prime p all over q squared. If p is equal to negative 1 minus y, then our p prime will be negative y prime, or dy dx. And if our q is equal to x, then our q prime is equal to 1. So now we'll plug everything in here. P prime is negative y prime, q is x, minus q prime is 1, p is negative 1 minus y, all over our q or our x squared. Now, we can just plug in our numbers. Everywhere we see an x, we can plug in a 1. Everywhere we see a y, we can plug in a negative 4. And we do see y prime once. For that y prime, which was equal to negative 1 minus y over x, we can also plug in numbers once we plug in for y and x. So we'll have negative 1 minus our y, and our y was negative 4. All over x, that's 1. So this becomes negative 1 plus 4 over 1. Well, that's just 3. So our y prime term will be negative 3 times our x, well, our x is 1, minus 1 times negative 1 minus negative 4 all over 1 squared. So we got to be careful with our order of operations here. Negative 1 plus 4, this is really 3. 3 times 1 is 3. So I have negative 3 minus 3 all over 1. That's negative 6. That is our second derivative at that given point.